Well, welcome to this webinar, which is about intervention part 1, and it's actually subtitled Prevention is Better Than Cure. Now, I'm here with my colleague Narelle.
Hi.
And she's going to help a little bit with the presentation today. And next week, Narelle will take a larger role in the section about, okay, there will be kids that slip the net for all sorts of reasons, including COVID, obviously, where we then will have to go back and look at some further interventions. But what we wanted to do this week was just review some key ideas in trying to help people avoid getting to what we're going to call a tier 1, tier 2, tier 3, or a wave 1, wave 2, wave 3 type situation. Now, I'll show you what I mean by that in a minute. We'll look at a diagram and so forth. But just before we start, I'd just like to check that you've got some materials. You don't have to have everything for this presentation, but in this presentation, I'll refer to mathematical vocabulary, and there's a free guide that you can download. We'll refer to the milestones, some that are just before you get to addition and subtraction. There'll be some milestones for addition and subtraction, another one for multiplication and division. Now, to participate, it'd be really handy if you had some grid paper or just some ordinary paper and a pen so you can do some drawing. That'd be really neat. And if you had some counters, I said 10, but if you had some more, that'd be handy. But that's all we'll need at this point here. So we'll get on a start and just give you a little bit of background to the idea of this notion of intervention. Prevention is better than cure. And a little bit of background. I know Narelle from several points of view, but one was I employed her many years ago when we ran a clinic for children who struggled with mathematics. And what both of us noticed was the same sorts of issues kept coming through. And if you can spot them early before the gap gets too large, you can fix it a little bit. So let's just talk a little bit about the theory and then we'll get on with the practical sort of thing here. So I'll just take you back to the slides and so forth. So in this case here, we've actually stolen this from the Victorian Education Department. It's a really good booklet that they've got on learning difficulties, a really neat information guide. And I suggest it's worth downloading. But we picked this out of one page of the book and you start to see this tier 1, tier 2, tier 3 idea. Now, our focus today will be on the green bit, the tier 1, teach well in the first place. That doesn't mean we haven't taught well. As I said, COVID could come along. Children might get a misconception, which is a fair enough sort of thing. Look, I'll give you an example how that might happen. A lot of our early mathematical work is with numbers larger than 1. Whole numbers. Okay, so naturally, up to about year 4, I think, multiplication does make bigger because my experience has been that. Now, we appreciate multiplication doesn't make bigger, but you don't get confronted with that until about year 4 when you start doing some work with fractions and decimals and so forth. So you start to see how it's quite reasonable that many children will develop some misconceptions. So we just need to be aware of it. That they will happen, but if we can be aware of it and spot it, we can prevent rather than have to cure. Now, what tier 2 and tier 3 say is, well, if I've given you a full rounded curriculum in tier 1 and differentiated it, that's what tier 1's about.
Very important there.
And that one there. There will be some kids that need some targeted support in tier 2, and there will be some others that will be very much individualised support in tier 3. Now, I know that you've been working with a lot of those kids in tier 2 and tier 3.
That's right.
And over the period of time, you've probably noticed some issues that they've had. So as we go along, I'll get you to, add your little comments as we do that. Now, remembering next week is more a focus, on the tier 2 and the tier 3. So we'll look at this sort of idea. But I recommend that book. It's got a lot of really neat things in it and so forth. Now, just to give you another little background, also in the Education Department website, there'll be a little section about misunderstandings. Now, people use different terminology like misconceptions, misunderstandings and so forth. But ultimately, that's worth having a bit of a look at, a play in that part of the website. It looks at common misconceptions or misunderstandings, which we'll talk about today. But it also talks about how you might assess to find that out and so forth. So
and there's some really useful little rubrics in there at different stages of the intervention process, what you can look for and what you can do.
Great. So there's some nice starting points. But let's get on the way and play with this sort of idea as well. Now, the model we're going to keep in mind over this week and next week, and we might embellish the model a little bit, is the notion of, we quite like the use of physical materials. However, better put a little caveat here. Just because you're using a physical material does not mean because a child sort of put this in their hand, picked up a block, that the information travels up your arm and into your brain. Yeah. And I'm a fan of using concrete materials, virtual materials as well. But sometimes children can misread or misunderstand those things. So can you imagine, Narelle, say, the big MAB kid, the big one?
Just got it. Yep. She's a little one.
Okay, yeah.
But when you look at that.
Yeah. Now, can you imagine that one? Now, lots of children that I meet, instead of seeing 1,000, in other words, 10 layers of 100, what they see is 6 faces of 100.
That's right.
And they read off that manipulative 600.
600.
Yeah. Now, that's not unreasonable because a lot of the new ones are hollow.
Yes. Right? I even saw a hollow see-through one, which
Right. So essentially that's to save wood and freight and, save the planet. Good thing. But you can start to see how just using manipulative does not guarantee that you will get the understanding. So there's a couple of other elements that I wanted to point out here. So we've got a visual image, we've got an experience, we can turn things and so forth. But what matters is how we link the language to it. And that's where we're going to be talking about it, writing about it, reading about it, seeing this stuff. And of course now we've got virtual manipulatives, so you don't actually sometimes get the chance to hold it.
Yeah.
Now, the other complicating factor in mathematics is this use of symbols. And the best way of describing it, whenever you use a symbol, there's a double labour going on in your mind. A bit like children whose first language is not English often translate the mathematics into their native tongue, forward and back. Well, when you use a symbol, it's like you're in a foreign language and they have to forward and back. Now, a classic example would be equals, which just literally means is. But we can get so complicated on all of that. Some kids think that symbol means adds up to, and they get really upset when you give them an equation and the answer's not on the right-hand side, it's on the left. And they're all things that we can watch for and so forth. So that's a model that I just wanted to bear in mind. And as I said, next week we'll look at how certain models can make a difference. Later on, even in this session, we'll talk about things that are countable versus a linear or length idea and how they give you slightly different notions and ideas here. So we better go on the way. It's enough of us talking. I want to do some things here and so forth. So here are the potential issues that we're going to focus on today. So one of them will be literally the language of mathematics. And let me illustrate it to you this way. You might find a child who can do the calculation 3 4s and tell you it's 12. Right? No problem at all. However, if you then ask them for the product of 3 and 4, they'll often tell you 7 because they heard the word and, or they have no idea what the word product is. And so many mathematics issues will actually be a prior language issue. And sometimes when we do some intervention, we need to intervene at the language issue so they understand what it is, so then we can... So we'll talk about preventing some of those. Okay? We're going to talk about counting and the idea of subitizing and mention particularly in that document. So Narelle, I notice you've got the learning difficulties document there. So that's the one we're referring to. And there's a whole section in there which talks about subitizing and link to a thing called dyscalculia. There's a bit more involved than obviously that's on that one page. But subitizing, magnitudes, which we'll talk about as well, come up. So if you want to follow that through, it's in that document that's already there.
And there'll be more next week.
Okay. It's a bit like tune in this time next week. It'll be fine. So we take you back to this. We'll look at some addition and subtraction. 3 major ideas I wanted to pick up there. Kids get so focused on counting that they then want to bring it into this addition subtraction idea. And so many of you will see children in upper primary go, and they're continually counting large numbers. 2 things will happen. They'll lose track of the count because they often don't recognise where it is, and there'll be one more or one less than the actual answer. It's dead giveaway for that sort of thing. Okay. Now the other thing I should mention is that curriculum does not just stop at the idea of just having strategies for adding and subtracting. You'll notice that in our curriculum in year three, it uses the word recall.
Yes, it does.
Now, we need to understand here that this will be a little bit different for different children. And we're not talking about putting you on the spot and saying 4th sevens are not fast enough. And, then you've got all those issues of the stress coming into place, and particularly these vulnerable children. Yeah. That's the last thing we want. We want them to have a productive disposition. But I still need you to be able to recall something. Right. Now, one of the reasons for that is, which we can talk about, it seems like I'm going to talk about a lot next week, but working memory in particular is going to be an issue. Yeah. The more things I have to reconstruct, it's going to clog my head up. So that's why I want some recall that would sit there. Now, in multiplication division, similar sorts of issues. We'll spend a little bit of time on the array concept, which is a fancy name for a rectangle, essentially. We're going to spend a little bit of time on division, because one thing that you picked up was a lot of your teachers only taught one sort of division mostly. Yeah. So we'll demonstrate that one, and you can start to see how that sort of impacts across your school. And then we'll talk a little bit about fractions and decimals, and hopefully we get there. hopefully we'll get all of that done in this particular time frame. So hopefully you're ready to go. We think we've got something that's worthwhile. Yeah. So enjoy sitting here. So here we go. So here's the language issue. Now, the Mathematical Association of Victoria runs some wonderful conferences, and so I picked up an article from one conference that they had, which you can download for free. Yes. It's on their website, but it's this idea of a Newman analysis. And so you can read the big detail, because we don't have the time today to look at how it's used, but let's just talk a little bit about this issue of language. Anne Newman was a teacher, and I love this idea that from a classroom, we now have something that's used fairly universally.
It really is. Whenever I read documents from overseas, it's Newman analysis, and it's like...
I better design something famous so it can be a swan something or other. But essentially, it gets to the nub of the problem, because this teacher, and she's secondary school, noted that many of her children were not actually getting to do the mathematics of the problem. So in this case here, she devised this really simple system, because she's a teacher, she's busy, right? So you can't be doing this one-on-one analysis. Yeah. And so it was as simple as, I'd say something, Narelle, would you read that question to me? Yes. So I'll give you an example. A question might just have one word in it. So the one that is actually mentioned in her writing was a question like 96 minus 48. Mm-hmm. Now, the child then gave the answer in hours. Well, hang on, what's going on? What is going on at this point here? Well, you can sort of guess what the child read for minus. Read the word?
Minutes.
Mm-hmm. Right? So then if you read the word minutes, you're in your head trying to come up with some way, how does this all gel together? Now, Narelle, can I get you to write that word down, okay? Because let's talk a little bit about the language here. So if you just write the word minute for me. And I've got Narelle to do this because her handwriting's very nice and mine's a bit ordinary. So there's the word minute, okay? But out of context, what else could that be?
I guess minute.
Okay, now here's an issue for us in the sense that they're both measurement-related words. One's to do with time and one's to do with the size of something.
They're both small.
Yeah, right. So you start to get this issue that it's complex. So I don't want to get too in depth on this, but I just wanted people to be aware that even just being able to read something. Yes. Now, of course, because you can read something does not mean that you know what it is.
No, it doesn't.
Okay, so that's the second bit. So I remember my twins coming home from school one day and they'd learnt a brand new word, Narelle. I'm not going to repeat it. And my wife was highly mortified at the thought that they had used this word. And I said, I guarantee they don't know what it means, but they've heard it somewhere. Children learn things despite our best intention. Now, essentially, we're not going to spend a lot of time on this. You need to understand that there's a thing called a Newman analysis. There are 5 basic ideas to it, but I'll be upfront with you. The first 2 questions will tell you a lot about your children. Can you read the question to me? Not out loud, not to embarrass them in front of other children, but privately as you're just doing your work in the desk. And the second is, can you tell me what it's asking you to do? Yeah. See, I might be able to read product.
Yes.
Right? But I actually may not know what it means sitting in. Now, the others are important, don't get me wrong, but a lot of the research will tell us that children aren't getting through the first two. Now, what I've done is linked it to our the Polya model for problem solving. So that's really under the idea of understand the problem. So George Polya is the father of problem solving. He wrote the book How to Solve It, and 1954, so it's a long time ago.
Pretty clever.
So he said, look, there's 4 steps. You've got to understand the problem, devise a plan. Well, to devise a plan, you really need to have done something similar that you can relate to. You actually have to do it. Now, when you do the plan, if you know what product is, but you still think 3 7s are 26, you've got a problem. Yeah. So even at that point, you can make a mistake. But some kids don't even know what product means to multiply. And the last bit is to look back, which for many kids, well, it's bad enough doing it in the first place. And often that'll have things like encoding. Does it need to be in meters? Are we talking about dollars? Are we talking about dollars and cents? Are we talking about that? So we won't spend much more time on that. I just need people to know that actually quite often it's a literacy issue. Now, this seminar is called Prevention is Better Than Cure. Yeah. So I need people to think a little bit here. The literacy people tell me, if you would look at the research there, if you want to comprehend something, you need to know 90 to 95% of the words in a text. That's a lot.
It is.
So now, if I know certain words are going to come up, I probably need to preload those words, and that's the prevention bit. Okay, so just to give you a bit of an idea, there's been some stuff recently in the news about NAPLAN, so sorry to use that word, but here we go. Let's just have a look at what we might be talking about here. So we've got the idea that we want to prevent some stuff. Okay, now I know that people in Victoria, that was a Freudian slip, wasn't it? Very naughty. Are very familiar with the work of John Hattie. Okay, now he would say in his book on visible learning and mathematics, vocabulary programs have a big impact. There's the effect size that sits there. So to get that going, we would need to have a list of words. Now the list is almost immaterial. You need a list. That would happen.
And you need the same list within the school.
Yeah, running right across your school. I think the teachers, they need to plan to use the words, but they need to pick them off the list. But the biggie is the children need to use those words. Now, to help you out, there's a guide to mathematical vocabulary. I've just put it on the my website. You're welcome to go in. You're welcome to print it. You're welcome to give it to your staff. But there's a little analogy there. Can you see the exercise bike?
I can.
All right. So my analogy is this. Lots of people have an exercise bike. Okay. So you can have one, but getting on it is a different story. That guide is really about not just having a list. Here are some things that you can do. It's just part of your normal teaching. So I'll give you one. So Narelle, I'm going to get you to write a word down on the board there. Let's say I was going to use the word pair. Right? Well, straight away we've got a problem. So I'll get you to write both of them if that's okay. So now we need to, if we don't write that on the board, children will have trouble distinguishing between that.
Yes.
So I need to explain that the top one's about fruit, and that's not the one that we're using. Very nice picture. Well done there. Yeah. And that's not the one we're using. We're going to talk about pears. Now, I would then need to explain. You're preempting me.
Sorry.
Yeah, that's okay. That's not right. But essentially here, I'm going to ask Narelle, every time I'm doing this as the teacher, I'm tuning you in with that language. Every time I say the word pear, now you can do it.
Oh, no, I was just making a pair of lines.
Okay, so I was going to say, I misinterpreted it. But here, I want you to put a tally mark. Okay? And every time I say the word pair.
Okay.
See, I wasn't explicit enough in my instruction there. Now, I know pretty well I'm going to have to use it 6 or 7 times minimum in a lesson to even get that idea. Now, I haven't even explained what pair is. So we have a pair of scissors. Well, that's got 2 parts to it. We have a pair of jeans. We have, where else will we have pairs? And so you're building all of that language, and I've nearly got there. But you see, straight away, I'm preempting this use of the word pair that will come up in it. There was one more.
This one. See, I got to engage.
Yeah, that was sitting there. So we got the idea that we need to have some vocabulary program that will help you get started. But just to illustrate to you how important that is, there's a list of NAPLAN words used in the last 8 years or so. I just put them together. I got the short straw on that book. All right, I had to go and look at all that stuff. But here's one little comment, and you might notice, you may not be able to see it on your screen, but you may notice there, Narelle, that there's as many words, if not more. I was
going to say a very long list on the one side of the page.
Yeah. So the measurement and geometry words, account for more language than number and algebra and statistics and probability put together. Now that's early on, it does change a bit later, but you start to get an idea that's a useful piece of information for preempting stuff. So I reckon that's enough that we've said on language.
Yes.
It's complex. We can talk about structures of word, we can do all sorts of things, but the reality is you need a list. That's your exercise bike. Then you need ways to get on the bike. Could be that you read children's literature. Now here's a plug for the Mathematical Association Victoria. They have the best set of children's books. Yeah. That's where I'd go. That's where I go and buy mine. Yeah. All with a maths theme. That's it on there. So anyway, I'll collect my check later in AV. That was it there. So here we've got this idea that sits here, the word list, but we've got to get on the bike. Let's do a little activity here, because you've been listening to me too long. Here's a bunch of chance words. Now, you can all read them. We've got like a little probability line. So, Narelle, I'm going to get you to draw a line. I'll just swap this over in a minute and we'll just talk about that. So, Narelle, I'm going to get you to draw a line. Now, essentially what we're talking about is probability. So, and we'll put a percentage on there, 0 or 0 to 1. Okay, so 0 being the left, no chance, zilch, absolutely none. Okay, to 100%, 1. So you've got to understand a little bit about a number line. And this idea of length will come up a lot more as later in the presentation and also next week.
Yes.
So we've got to understand length. Now, if I take us back into this point here, this is just something that I've noticed working in certain schools. And take the first two words there, possible and probable. Well, they sound pretty much the same. They have about the same length. They relate to a thing called probability, and yet they're quite distinctly different. Okay, so we'll notice here, for example, the bottom word I put is impossible. So let me give you an example. Lots of people put like a dichotomy. So on the left-hand side, impossible that's great, because it is impossible, 0, zilch, no chance whatsoever. There's your impossible. But I noticed when working with children that they often put the word possible right on the other end because they think there's like a dichotomy that's going. In fact, you might want to use a different colour here, Narelle, just to make this really clear. The word possible applies. You want to show us where it applies from?
Oh, I would say anywhere as small as I can get after that 0 down.
Yeah, all that way.
Possible.
Yeah.
And I think, when we teach English, that would make sense for children to think about impossible and possible because we talk about the prefix im.
Yeah.
And so,
So you can start to see it's not bad teaching that's led to it. It's a natural. If you can construct knowledge, then you must be able to misconstruct.
Yes, that's right.
Now let's take the word probable.
Okay.
Probable is actually not going to be all of that, is it? If it's probable, it's more likely. It's probably to the right of about the 50-50 mark.
I'm just going to put a half in.
Yeah.
I'll do that in my blue, in the middle. And then I would say after or greater than. Is that what you were saying?
Yeah, because and that's an interpretation that's probable. It's more likely. So now I've used the word likely to explain, and if I know what likely is,
maybe highly probable.
So if we go back to the list of words there, you start to see maybe.
Yes.
Now, when my children, particularly when they were younger, if they asked me a question, right? Can we go to the park or something? My answer would be maybe. which they realise means probably no chance. But let me pick a couple of others there. There's an expression like Buckley's. Yeah. Now, if I speak a language other than English at home, you've got Buckley's chance. Now, there's a couple of stories behind it. I won't go into it deeply here, but you need to know the cultural background to that language. Once in a blue moon's even tricky. Look, it can happen about once every 13 months. So it's actually more common than you think. So I just want to illustrate to you how sometimes the language gets in the way of the thinking and so forth. So we better keep moving because I understand people's time is valuable and they'll do that. So that was the first thing that we just want to talk about. If the kids don't get the language, then they won't have the understanding. If they don't have the understanding, then they're going to struggle. But not only that, you've worked as an intervention teacher.
Yeah.
So then when kids already come to you with these misconceptions of language, then you need to be fairly precise.
Yes.
But even you would see the quizzical looks from the kids, even if you use the correct language, may not
Yes.
They look like they're nodding, but actually not getting it.
Yeah, that's entirely right.
And that's part of this prevention sort of stuff. So let's just continue moving on and look at the next idea. So I just want to spend briefly a bit of time on counting. You're welcome to download this, anyone who wants to. This is just a bit of it's a compressed trajectory of this, because I could expand it. If we were working with children with learning difficulties, I've got a bigger expanded one. But essentially, you think about counting, there are certain principles. And once again, did you notice here I've listed number one, I've numbered it, a stable order of counting words.
Yes.
See, can we put the counters just on, put say 4 or 5 counters on them place here. If I don't have the words right to start with, okay, and we'll keep them all the same colour because children have trouble, well, that'll be a real issue for them. And notice Narelle's put them in a bit of a scattered arrangement. For some children, they can only work left to right and all that. But let me count. Let's see, I'm going to count 7, 4, 6, 2, 9. There are 9 counters in that set. Now, if you think about what I just did,
you demonstrated some of the principles of counting there.
Right, but I didn't do the
first one. No.
And so, whether I like it or not, there's a hierarchy here that if I don't know that number words come in a particular order, everything I do from that point on is wrong. Now, the reality is, it'll depend a bit on your postcode.
Yeah.
Need to be upfront about that. Depends on the rhymes you've learnt, the books you've read, all of that sort of stuff. And then there's a possible of other things like a one-to-one correspondence. The last name I said was for the set.
Yes.
Now, you might notice here that all we're using is the standard counter. We haven't even changed the type of counter. We haven't got the fruit counters and some kids can only count left to right. For example, if I said to you, Narelle, I want you to make this one number 3 in the count, there would be lots of kids who would struggle trying to work out where to count. Yeah. Now, I don't want to go into great detail on that. Victorian Education Department has a lot of stuff on the counting. There's maths assessment interviews, all of that stuff. We can make observations. But what we need to appreciate is if you miss any one of those, you could have troubles later on. So even the notion of the order of relevance, the abstraction and so forth. Yeah. Now, that's all we're going to talk about in counting. Can look at it in more detail, but there's a couple of other things that go on that I think matter, and we've tried to sort of list some of those. Now, some of them, you've noticed in my little slide there's a blue section, that's the counting section, but there's some things just before it. So, for example, in the document we had before, remember the learning difficulties one, if you just want to grab that for us, there was things about things called subitizing. Okay, there were things about order magnitude.
Yes.
All right, so that, which is the larger number, or things like in a sequence of numbers, which is the missing number. Yeah. They're all mentioned in that document. So I'll just show you, if you want to turn that up, then people can see where it is. There's a whole section on it. It just comes up here.
I did have it.
That's right, doesn't matter. There we go. And there we go. So there's the section on subitizing, approximate magnitude, etc. Okay, so once again, we've got limited time today, but there's quite a good little section that we can read on there. So that would be one of those bits, and that understanding of the magnitude links to a thing called a number line, which once again becomes a big deal. And if we're talking about prevention and rather than cure, then the number line features a lot, and you'll see it if you look on that. If you look on this yellow document here, about halfway through we start putting the idea of a number line. Now that's got small jumps. Later on we move away from counting in ones because that's a real problem. But the number line is the precursor to things like any scale that you will see. So in year 3 or 4, you think about all the scales that you're going to come across. Think about there's a number line goes around a circle that's called a clock. So you start to see number line is a big deal, and it will feature in even things like fractions. So just wanted to make that awareness of that one there. So that's on the little counting sort of bit here. We won't go into detail this week about what they call predictors, but
next week we're going to.
But obviously we've mentioned some of those. We'll talk a bit more about working memory because a lot of children you work with have that trouble. But the subitizing is one of those things that sort of comes up fairly regularly. Now, if you're welcome to look in my website under the interactive tests in the Siren set of material. That's free if you want to check how your kids go on subitizing. But there's a bit of benchmark. By the end of year 2, we're looking for some knowledge. You don't have to be fast, but some knowledge of basic addition facts. That means you can do something like add 8 and 7 by saying maybe 8 and 2 is 10 and another 5. Well, now that's not easy. There's a lot of things that I just did there. If you think when I added 8 and 7, I split the 7 into 5 and 2. Partition. Yep. Okay. I had to add 8 and 2 fairly well. I had to know that I could turn it around.
Yeah, we could show that.
Yeah, you want to show that? Yeah.
So you had 8, if we just look down here, you said 8 and 7, did you?
Yep, so I did it 8 and 7,
so you did 8 at 7, and then you were saying you had to split your 7 into, did you choose 5 and 2?
Yeah, and that, I could have chosen 4
and 3.
Yeah,
I was going to say that wouldn't, but then you actually didn't use it as 5 and 2. You actually used it as 2 and 5, didn't you? Okay, and then the reason you did that was because you wanted your 8 and 2 to be, I'm just going to do it like a part diagram. So part add part, and then you knew it would be the 15.
Yeah.
So you had to have some knowledge of some facts, yet have some understanding about the commutative property of addition. It's pretty complex.
And what you've just demonstrated there, even with what I said so quickly, I said it, we could draw it, we could use the materials, we can talk about it, we can, and prevention's better than cure if we do that, but I know you did that very deliberately. You've obviously cured lots of children.
We'd hope so.
So basically, we'll talk a bit about that, more about that next week, but just be aware there's these predictors. However, the big issue for me is that sometimes what happens, well, not sometimes, often what happens, you would have met them, children in year 5 and 6 who are doing...
It's often very subtle. Just tapping on the desk.
Or
eye nods.
Or and under the desk is very common. Yeah. But if we're watching for it, we can spot it. Now, that's very hard to cure. It's like extremely difficult. So what we're trying to do is avoid that. Now, let me give you an example here. We've talked about this idea of concrete representational abstract. It was in that triangle diagram we started with. But many of our concrete materials are countable. So, tens frames are great material, don't get me wrong.
Essential.
Perfect material, right? And in fact, if we want to prevent, I want a 5s frame, I want a 10 strip, which is about length, so we're getting that magnitude, length stuff, and then a 10s frame, that happens.
We're going to go into that a lot next week about why that is important.
And even here, we put them in 2 colours because they're building this part whole, which I noticed was the language that you used there. People might know that sort of Singapore maths idea, the bar diagram.
Tape.
Whatever you call it, because it goes by different names. And essentially what you've demonstrated with the box is that sort of idea. What we need to be careful of is if we stick to just the single counters all the time, we're not encouraging children to move from that counting. And so here's where the next bit sort of fits in, I think that makes sense here, that we need to, when we're doing our basic addition facts, we need to move away from this counting idea. Okay, so counting's good. There's nothing wrong with it, but counting too much is going to give you some. We know that's going to be a problem, and so we want to try and avoid it. So that's partly why I put together the milestones. And look, I'm happy for schools to cut them up, do whatever they want, but there's a distinct order in which things are taught. Okay, so let's pick the first one. You count on. Now this is going to be pretty tricky. You count on from the larger number by 1, 2, 3, or 0. Now let's just break that down a little bit. We talked about number magnitude earlier, and I just said you're going to count on from the larger number. But if you can't identify with 2 numbers which is the larger one, how can you do that strategy? So let's imagine I said to you, I want you to add 2 and 7. But if you don't know that 7 is the larger number, we can't do anything. The other thing is I've got to be happy that it's okay, even though I gave it to us 2 and 7, that's an understanding that we can turn it around. And then I've got to hold the 7 in my head and count 8, 9. Now, if we let kids count too much, we just shot them in the foot in terms of their short-term working memory. So that's why we say we're only going to let you count on up to 3. All right, that would sit there. Now, at the end of all this, in this document, you'll see that same idea, we want to get some recall, right? So that we can, now that doesn't necessarily mean very super fast at this point. I just need to recall some things. But I also need to make some links with a thing called part, whole thinking. So can I get you to put another one out here? Let's go with 5 and 2 as 7. Okay.
With counters?
Can we just do it with the blocks? Just
yep.
Okay. So yeah, we'll do a couple of different, and we'll just show this just briefly. Time's going to be run ahead of us. So we've got now, we're using 2 distinct colours, and so you'll see it here.
Yep.
Okay, so we've got, now there's a process when I'm joining those things together, but then often kids will go 1, 2, they count them all, as opposed to hold the 5, and then where's the next number comes? 6, but they'll often say 5. Okay,
so that's what they're remembering.
Yeah, because that's the last thing I said. So they've got to learn to say 6. They're holding the 5, 6, 7. If they count it on much more than that, it's difficult.
Yes.
Now, what you will notice is kids who count ones. So can you swap to the blocks that don't have any markers on it? And this will make more sense.
You'll notice they're the same size.
Okay. So in this case here, I have to, the 5 is, I can't count.
Yes.
And that's one of the big deals that we're going to pick up here. Yeah.
Just go.
That was it, and then you've got the idea.
Yeah.
Okay. Now, as I said, we can spend some more time next week on that one. But I just wanted to illustrate this issue about counting and why we want to move away from it. Okay. So you're welcome to download that, play with stuff. You'll notice all on that is things like 10 frames. Yeah. Lots of kids move away from it naturally, but the children that we're talking about don't. So if we want to prevent, we need to change the material. We love materials, just think about how it's working in that sense. Okay, let's talk about division. Now, essentially, we talked about predictors earlier. There's 2 big predictors, particularly going upper primary, lower secondary, and surprise, surprise, they're division and fractions. Okay, you can look at that research if you want, but it's pretty good research that's it there. So we've now jumped quite a bit in it, right, in this bit here, but not all your children are going to struggle at that end. It's when we move up the school that would happen. So we're going to spend a little bit of time on this idea of division and fractions. And once again, there's a set of milestones that we can have in place, and we're learning certain things at certain points.
And just, you say they're sequenced, but it is subtle. You'll notice they have little arrows at the bottom of each strategy. They are sequenced for you. It's very specific.
Look, if you've got some children in year 5 and 6 with these struggle, that's fine. You just shift it across, but they're taught in a particular
order, based on
deliberately.
Yeah.
Okay, so in this case here, let's pick the one key idea. So we've got some a grid there. Pretty sure. Yes, good. Okay, so we've got our grid, and essentially, grid paper is going to be your friend. Now, if you've got some paper with you, you might want to do some drawing as well. That would sit there. We're just going to use a whiteboard and a pen. But remember we talked before about the idea of linking the physical, the things you can see and so forth. Yep. So I'm going to start using the word an array, but an array is just a rectangle. Okay? An array has length and width. Okay, they're the dimensions of that rectangle. Now, that length and width is actually referred to as the factors. So we're going to have a factor and another factor produces. Product is an area. So factor, product. Earlier you used part, whole. Okay. Now in this sense here, I'm going to give it to you as the dimensions of a rectangle, and I'm going to use the word by. Now if you don't know that by implies you've got
money.
Yeah. So now we've got a by, and we're giving dimensions, and you start to see how language is going to come up in all that. Let's keep it really simple, Narelle. Can you draw me a rectangle, an array that is 7 by 0? All right. Now, hopefully you're struggling a bit there, but I don't know how many children I met that tell me 7 zeros are 7.
They draw 7 by 1, or 1 by 7.
Now, here's a classic example of, that's not a bad misconception, because when they learn to add, 7 and 0 is 7.
Yes.
So when you add, it doesn't. So they then sort of think, well, that works here, and I just naturally apply it across to here. But until I get you to do some drawings and we look at, hang on, it's got no dimension. Well, now we could use a thing called cognitive conflict, for example. So if you drew me one like that, so can you draw me what 7 by 1 is, and all of that. Now here's one I would like you to draw.
Yes.
And we'll just talk a little bit about the language here. Can you draw me a 3 by 3 array?
3 by 3.
Yeah. Now, what's happening here is that Narelle, if you watch here, she's gone down a column and she's gone across by rows. Now here's some language that we need to talk about. Rows always go across. Okay, so they're moving across there. So rows always move across. So when I'm initially teaching this idea, and we need to be explicit about that, really bright kids will work this out. So can I get you to draw me a rectangle that is 3 rows of 5?
Rows of 5.
Yeah,
okay.
so rows always go across.
1, 2, 3. Rows of 5?
Yeah.
Yep.
And 3 rows of 5.
Want 3 rows of 5.
Okay. And that gives us that rectangle. Okay. Can I now get you to draw me a rectangle that's 5 rows of 3?
Rows of 3. Okay. So rows of 3, and you want 5 of them. I know that was 3 and 2 more.
Now, bright kids just get the fact that 3 5s produces the same area, same as 5 3s do. But children who struggle don't. And that's the issue where we may need to be much more explicit. Even doing that drawing is not going to be enough.
No.
It's physical. You're going to get the scissors out.
Yeah.
You'll be cutting that piece. You'll be superimposing on it. You'll be doing so much work.
Yeah.
But if we skip the bit about arrays, I know you're going to pay for it.
Yeah.
You're going to, I mean, you don't know how many children I meet. They can't get over the fact that I do maths all day, right? That's a real issue for children. But the second thing is, I think I'm there to test them on tables.
Yeah.
And I had a girl the other day, I know what 8 3s are. I said, what are 8 3s? She said 24. I said, so what are 3 8s? Oh, we haven't done them yet. And so you could see the look in her mind about, these things all go together.
Yes. Yeah.
And in fact, I like the notion of a fact family. If you've got kids forgetting things, it's because they're learning one individual fact rather than linking all those things together. So I'm not going to kid you. One go, this is not going to be the answer for you. You would play some games like the arrays game, focus on some specific arrays, draw a lot. Now, even then, so a classic example would be, if I ask a child what 5 rows of 3 are, the counter, remember we talked about, we'll go 1, 2, and keep counting, right? So then I want you to be a little bit more efficient. Maybe we can count in 3, 6, 9, right? Which is a skip counting, or 5, 10, 15. Right? But there are means to an end. At the end, I need to know 3 5s or 5 3s are 15. Now, bear in mind, here's a language issue. It's not fully correct for me to say 5 3s are the same as 3 5s. So if doctor said to you, take 5 tablets 3 times a day, or 3 tablets 5 times, it's different. Now, if you look in the milestones, it talks of the idea of lots of and groups of, and this is array. So there's more than one concept. That's why we need to spend time on the understanding before we rush into the stuff. And here's where teachers are often under pressure, because what happens is you're the year 3, 4 teacher. So you got some kids who didn't learn their addition stuff in year 1 and 2, so you got to make them a bit faster, recall in year 3. You got to start teaching them about tables and multiplication and division. You've also then got to look at the idea of, so I'm also doing time. I'm also starting to do fractions, and I'm also going to get you in year 4 to 2 decimal places. No wonder we're under pressure. Yeah. But here's an example where if we rush this, we pay for it down the track. This is the prevention bit. So the idea of that. Now, can we make the same comment about division? Because you made this comment to me earlier that many of the children you work with had trouble with division. So we'll look at division. There's the arrays game that I mentioned before that you could play. And once again, you can download that from my website. So Narelle, I've got you set up now. So you're ready. So there's 2 sorts of division. And we'll leave the slide there for you. But I'm going to let Narelle demonstrate this. One is a sharing, brackets, partition. And the other one's quotition. It's a big name, but you'll see the demonstration as we go. So you've noticed this a lot with the kids you work with, so let's just talk about it.
And I think when we first look at the content descriptors, it says in year 3 the division by grouping, but when you go further and look at the elaborations, it actually talks about both types of division here. So the first way that we usually start with division, and what I see a lot of teachers do, which is a great start, is that sharing idea.
And sharing's a natural idea.
That's right, and it's where we start. So we say 12 counters shared between 3 children equally, how many that they get, and we tend to have the 3 children, and then we do the methodical sharing like we do. And we're quite good.
And that's an example of an action? Because we talked before about the story and an action. Yep.
And when we go from that concrete, representational, abstract, we're very much very much using this concrete with one-to-one correspondence. But
which is like that counting thing that we went on about.
That's right. And we get so involved in the counting and the action, that's the beginning. We need to move on to more of a representation. So instead of grouping the counters like that, if we just simply made them into an array when we did it, we're then able to move on. So just by a simple changing of how the materials are structured, I can then look at the sharing. So here we have shared them and they each get 4 counters. Yes?
So what we said before is we like to use concrete materials, but it's more than just having the material. It's the way you use them.
It's the way you use them. That's right. So this is that sharing idea or the partition, that you have shared them equally. But you can also do the grouping or the quotition. So to move from here to the grouping, you would also see, and I'm going to use
and the story changes.
The story changes and the picture's actually going to change
Is that language
as well.
again? Yeah.
So I would actually have a story written in words. There were 12, and we'll stick with lollies.
Yep.
There were 12 lollies shared between 3 children. They each got, and I'll do it in the blue because that's the colour I did the circle, 4 lollies.
Yep.
And I would write those words and then match them to each part of the equation or number sentence. After we've done a lot of that, we then want to do the grouping idea. And this is why I structured it this way. Because what if we grouped the lollies this time in bags of 3? So I'm not looking at sharing between people anymore. I've got the same number question. I've still got 12 divided by 3. But this time I am grouping them into groups of 3. Now I would have rubbed out the blue, but it's just going to smudge everywhere. But you can see here, this is a bag of 3. This is a bag of 3 and a bag of 3 and a bag of 3.
Yeah, so I have 4 bags.
So I have 4 for what? I have 4 groups of 3 lollies. So we've got the same array, but we don't tend to do the grouping as much as we tend to do the sharing. And do I have a second to explain why they're important?
Yep.
So the reason they're important is that when we go up the school, sharing is really important for things like, so we've got sharing and we've got grouping. And if I want to do a number like 1 divided by, can I do 0.2, is that?
That's okay.
Okay, all right. Grouping is the idea of how many groups fit in. And if I understand how many groups of 0.2, which is actually 2/10, how many 2/10 are there in one whole, that makes sense. I can see it. 2/10, 4/10, 6/10, 8, there's 5. If I only have a concept of sharing, you try to do 1 lolly shared between 2/10 of a person, it makes no sense. Okay, so when you want to in later school divide by a number that's less than the starting number, you're in trouble. And then similarly, if you do it the other way round and you want 3 lollies shared between 4 people, which is actually 3/4 of a lolly, that if you try to do that with group, if you only know grouping, you only know into, how many 4s fit in? It makes no sense. So we actually do need a balanced diet of both types.
So if I break this down, this is a common thing you've spotted in your school, but we started with we need a conception and understanding, and I noticed you brought back arrays.
Yes.
So that's how the link between multiplication and division will happen. 2, we have 2 distinct conceptual ideas, the sharing and the grouping.
Yes.
The actions are different. That's it in there. and what you're suggesting is one gets done more often than the other.
Yeah, and in different schools, different people feel more confident. If they did a lot of the algorithm and they're doing a lot of into, they might not be as good at the sharing. But we need to make sure we do both.
So your tip for prevention is we need to do both.
Teach both and link that concrete material, the language and the symbol.
And that's what we started off with, that general idea. So essentially, there's the one sort, some bits, and I'll put there's the next sort. I'll let you read that at a later point. That would sit there. But they're two different stories. Different actions. Yes. The lolly bag's the classic one when you're putting the lollies for a party or something like that. That would sit there. So we got the biggie, and we haven't got much time, but I want to talk a little bit about fractions. And now we've got some strips of paper there. Narelle's going to be my guinea pig. But fractions, they're the bane of everybody's life. But essentially, you alluded to a fraction just then. It's a form of division that sits there, and often people don't see that notion. Yeah. Now, the other thing is there's a lot of language in here. Yes. So, Narelle, I'm going to talk you through this, but a couple of points. I've used this same diagram that we started with, essentially. Okay, and we've taken a region. Now, you notice it's rectangular. I'm not against circles, but to understand a circle is quite involved. You've got to have a rough idea of something to do with angle. You've got a whole pile of things. It's much easier for a child to divide one up. Yes. By the way, I want the child to do the division, the partitioning, right? It needs to be them doing it. Yes. That's why a strip of paper works really well. Yes. The second is there's a bunch of language that goes with this. So in this presentation, I'm going to use words like denominator. Now, denominator is not a common word that people get. It's got nom, to name in it. And if you think about churches are named by their denomination, currency, denominations in currency, it's the same idea. But most kids probably aren't going to link those words because it's not in their typical experience. So we wanted to about name, how we name the fraction. And now lots of kids will tell me it's by the number of parts. Now here's where a misconception can develop. It's actually by the equal parts. Now it's a small thing, but if we pick that up early, we got some prevention. So the other bit will happen is often children have what they call a whole number thinking to this. And because I see it a lot, I can hear it. Okay, so for example, in this case here, if someone said to me, that's 3 over 5, I can almost hear that they've got this whole number thinking. And that person will think that 3 over 8, because 8 is bigger than 5, is a bigger fraction. They don't realise the parts are smaller. The other thing here is I would always start with unit fractions. 1/8 or 1. I've got 3/5. They need to be the same.
So the unit fraction having the 1 on the top.
And the numerator. Now the numerator is just the number, comes the word number, the number of parts. So in this case, we happen to have shaded 3 of 5 equal parts. Now I'd want the kids to do the part, I want them to do the shading, not to see stuff already done. So very quickly, Narelle, so we're going to let's look at this because we need to finish it. We need to establish what the whole is. Yeah. Everything else is unrealistic if you don't know what the whole is, the one, the unit, and we're going to use this green strip to illustrate that. Could you please now fold lengthways for me, the blue strip, in half. And essentially what's going to happen is there's actually only one fold point, but we get two equal parts. Yes. Now for some children, I would actually get them physically right 1/2.
I definitely.
As the word, right? Because we got to go to the symbol is a big deal later on. Yeah. Now we can talk about how that might move up and so forth. Now, can you get you to fold the yellow strip in half? And then what I'm going to say, and then in half again. Oh, right. So now this is tricky. We're actually multiplying a half of a half. And, doesn't multiplying make bigger? Oh, right. And see, this is where we start to get this issue. You're going to have to mark them in so they can see this bit here. But now, how many equal parts do we have, Narelle? 4. But we actually only have 3. This is really interesting in itself. Now, I'm going to call them fourths. I know they can be quarters, that's fine. But what I'm trying to do is most fractions are named by their ordinal number. So, tooths doesn't work. So but you got thirds, and I want to break that sequence because I want the pattern. Fourths, fifths, sixths, sevenths, and so on. Now, later on, I'm going to use quarters, but just when I'm establishing the pattern of the language, this is a language issue as well. Now, what do you notice about the size or the length? Because we're looking, I know it's got an area, but the length of that fourth.
It seems shorter than the half.
Oh, so what do we? We're not going to find it from 1.
No.
And we're going to move pretty quickly because our time's going to run out. But can you just fold now in half?
Can.
And then in half again.
Yeah.
And I often use A3 paper for this a bit. Yeah. And in half again.
Can I tell you what 90% of the children tell me this is going to equal?
Tell me. Yeah.
6.
Okay, because they're not getting the multiplying idea
Nope.
that's happening there, which is fine. So I'll get Narelle to mark them in.
There's not 6.
Okay, and we've got this.
There's
and
8.
that's the advantage of the kids physically doing something. And look, I'm not against fraction walls.
No.
But there's no sense in using a fraction wall until you've done this sort of thing. Now, let's have a look here. So we've got this thing called eighth. So one part, we need to make clear, because I need to understand that one part represents 1/8. Okay? And as we said, we'd probably write it in words and all of that stuff before we did symbols. Okay, that would happen here. So hang on. So you're telling me 1/8 is not as long as 1/4. It's smaller, right? But children have the conception of the whole number thing. Will tell you 8 is bigger than, which it is when they do whole numbers.
Yes.
And that's why I always listen for the kid who says 1/8. Because I think they've got that notion that sits there. Now, in essence, we'll have to wrap this up.
Yeah.
But what's happened over this presentation is we've talked about this concrete representational abstract idea. We've talked about the fact that if you think about it, you've got these concrete materials which do help, but can also lead to misconceptions if not done well.
Yes.
Or if we skip, like see that one we just did. So we've got these, the strips.
Yeah.
If we just went straight to a visual model or pre-made stuff.
I was just, I know we're short on time, but by all of the pre-made stuff, they put the denominator in.
Yeah.
And it's the denominator and that understanding that the more pieces you divide it into, the smaller the piece gets. Yep. And unless they do the denominator, which is messy and hard and time-consuming, but that's what you're saying about this prevention is better than cure. Put the time in, get them to do the...
Look, there's no doubt it'll take longer. I can't kid you about that. But you're going to spend far less time on revision lessons. Hopefully less kids getting to that level 2 and level 3 on their bit there. Now, I would take those strips and actually make a poster out of it.
Yes.
We'd go on the wall, and then the next lesson comes, we would talk about reuse the language.
Yes.
Do you remember, I've got to use those words many times. Yeah. I need you to use those words. There's a visual reference that sits there. Look, I know we've moved fairly quickly. Just a reminder, there's a book that's available from the Victorian Education Department website. Got a lot of useful materials in it.
Yeah. Lots and lots of links.
Yeah, and look, essentially there, if you think about it, we've just been giving you some ideas here. Next week, we'll talk about, okay, there will be kids through your best intention that have slipped the net. For all, COVID's going to be a classic example of that. Yeah. So it's no fault of anybody's here. No. But there's actually a lot of work to do to unravel a misconception and then redo it. So thanks, listener, and look, thanks, Narelle, for participating and
thanks
using
for having me. Yeah.
That's it. And now next week, Narelle gets to run things, and I'm the guinea pig. So thanks very much for listening to us.
Thank you. Have a great day.
Bye.